Welcome back to CVN 5370 GIS Applications in Engineering. In this video, I'm going to present the outline of our course. I'm also going to talk about some of the prerequisites that I expect you to have, as well as introduce you to some tools and technologies that we'll be using to implement GIS solutions. So let's start off by looking at the course outline. I'm going to start off by introducing what GIS is, and I'm going to compare and contrast GIS with other complementary technologies such as CAD and BIM that are widely used by civil engineers as well. After that, we will make a detour into geography and then learn some cartographic concepts that are important to us. Cartographic concepts mainly deal with making maps, but also understanding how locations are measured on Earth. And for that, we need to model the shape of the Earth. There are different models available, so I'm going to discuss some of the common models that we use to describe the shape of the Earth, both in the horizontal as well as in the vertical directions. This will get us a good standing of understanding geospatial information. And the next part of the geospatial information is the actual data that is stored. And for that, we will venture into computer science or techniques of computer science a little bit, particularly the relational database concepts. Relational databases are databases where we store data in multiple tables that are related to one another using the concept of keys or key attributes. Using these key attributes, we can merge information from multiple tables and take different views of the data that are available to us. This essence is making the data ready for GIS analysis. So relational database plays a very important role in GIS modeling, just as important as geographic concepts. So essentially, we're going to learn some geodatabase concepts, particularly the use of structured query languages to assimilate data from multiple tables and make them GIS ready. Once we have the geography and the data integrated, then we are ready to perform geospatial analysis. There are a variety of different models that are available to us to represent geographic objects. We can use what is known as the vector model or the raster model. And there are some newer data models such as NetCDF and HDF that particularly help us integrate space and time data into a single file format. So we'll look at some of these data formats. After that, we'll also be looking at tools for implementing GIS. I'll be looking at the conventional GUI-based approach or the graphical user-based interface-based approach, where we perform GIS manually using menus and processing tools and such. And I'll also look at programming-based models, which essentially use GIS for geoprocessing data using computer programming languages. In all of this, we are going to study a wide range of applications in civil engineering, particularly site suitability analysis, which is typically used in geotech and environmental applications. We're going to look at transportation networks. We are going to look at what is the least cost path to move from point A to point B, origin destination analysis, what is the best way to move people or goods from one location to another. We're going to look at watershed delineation, which is a very classic problem in hydrology or a very fundamental concept in hydrology. We'll make use of some modern tools and technologies such as LiDAR and drone data and see what kind of information we can extract into GIS from these technologies. And I'll also expose you to some remote sensing data sets, which can be used in a wide range of applications, such as developing land use, land cover, understanding land use changes, land cover changes, and such. Particularly the use of optical remote sensing data that's widely available for us. So to do all this, I expect you to have some prerequisites. I expect you have a traditional Bachelor's of Science degree in civil engineering or a related field such as agriculture or environmental engineering. I want you to have calculus through differential equations, so you should be able to solve some ordinary differential equations, the first order or the second order type that we typically teach in an ODE class. I want you to have some understanding of civil engineering systems. The most important skill for learning GIS, as you can see, GIS integrates concepts of geography with concepts of computer science so that we can take these concepts to solve some civil engineering problems. So in addition, you need to have what are known as computational thinking skills. Those are the basic skills that I expect you to have in this class. Some programming background is useful, but if you have not had programming classes or hands-on programming experience, and that shouldn't deter you from taking this class. Although keep in mind that learning programming occurs through making mistakes, so you should be uh, willing to put in the work to make mistakes and learn from them. We'll be using several pieces of software in this course. We'll use QGIS, we'll use the Jupyter notebooks for running Python code, we'll use GDAL, which is a very popular tool for geographic data abstraction and analysis. We'll use Saga, which is for watershed delineation, R, which is a statistical programming environment, as well as SQLite, which is a relational database system. Our approach is I'm going to teach you GIS from two different approaches. The conventional approach is using graphical user interface and making manual workflows. This approach is traditionally how GIS has been done for a long time, but it is slowly being replaced by programmatic approaches. Conventional approaches, particularly using GUI, still are very useful. If you want to solve a small problem, you don't need to write a computer program. You can just simply do it using GUI tools such as the QGIS that I'm going to use here. You can also test out your logic on simple problems using these conventional tools. So they're never going to go away, but their usage is certainly shrinking in the industry. Saga is a system for automated geoscientific analysis. So this is something we're going to use for delineating watersheds. On the modern approaches sides, we're going to be using Python and R, which are two general purpose programming languages essentially designed for scientific computing. We're going to run Python through Jupyter notebooks, and we're going to run R through RStudio. Behind both the conventional approach and the modern approaches lies the GDAL, and GDAL stands for Graphical Data Abstraction Libraries. A conventional approach or the modern approach essentially take GDAL tools and write wrappers around this GDAL tool to make the type of calculations that we'll be doing using various pieces of software. So understanding GDAL is useful because that is the engine behind a lot of computation work, including commercial tools such as ArcGIS, which we will not be using in this class. SQLite is the relational database. This is widely used for modern geoprocessing tasks and for integrating data models such as GeoPackage model. We make use of SQLite, that widely used relational database software. So that again forms the basis for doing what we want to do, regardless of whether we use the conventional approach or the modern programming approach. So I mentioned in the class that computational thinking is important to have for learning GIS. What is computational thinking? Essentially, computational thinking means that you are able to logic out things, you are able to evaluate and make judgments, and you are able to write down steps, a sequence of steps needed to perform some task. This is also known as algorithms or algorithmic thinking. Patterns, it is like looking at patterns and saying, well, this looks very similar to this. Can I use this, what I've developed, a solution A to solve solution B? Decomposition is essentially taking a problem, breaking it down into manageable tasks, and then performing each task using the right algorithm. And abstraction finally means removing unnecessary details and presenting what is the most important information so that information is conveyed without loss of clutter. So these logical tools or thinking tools or abstract thinking tools are not only useful for GIS, but also useful for engineering design. We use the same thinking. So you can think of it as honing your skills or your computational thinking skills that you have already acquired at your undergraduate level or with your master's level, and using them to become better at thinking abstract or logicking out workflows, figuring out which steps comes first, which steps comes next, what type of data are necessary Do I need to keep all the data or can I remove some of it and things like that. So you will be tinkering, you will be creating, you will be debugging, and of course, you will be collaborating. That is a very important task. It is very difficult but useful, as well as you will persevere as you go through this whole process. That is also an important skill for engineers to have, and that is something programming is a great way to learn perseverance and patience and learning from mistakes. So, computational thinking will not just make you good at coding, but also a very good engineer and a geospatial analyst. So, I strongly recommend that you pay attention to these computational thinking tasks as you go through the course and evaluate yourself how your computational thinking skills has improved over the course of this semester. There's a lot of buzz on generative AI tools such as ChatGPT, Copilot, Google Bard, and such. I want and I will be using generative AI throughout this course. Some examples of correct uses, such as what is the best way to prompt for coding syntax, asking it to show small examples that can serve us to write our code, ask us to summarize GIS concepts, things like that. Can Gen AI does a very good job, but of course, if you feed your assignment that I give to you into Gen AI and ask you to solve, in all likelihood, you will get a wrong answer because Gen AI has not seen this particular example, so it won't know what to do. If you cut and paste output and submit that Gen AI generated solution as homework, clearly that is plagiarism and will result in a failing grade. And at the same time, if you make use of Gen AI, it's important that you recognize Gen AI's role as well. So you need to acknowledge Gen AI when you make use of Gen AI. So one of the ancillary skills that you're going to be learning in this course is the use of Gen AI, prompt engineering, and how to use Gen AI to make your learning more efficient and easier. As an example, I asked Gen AI how good are the answers provided by Gen AI on GIS. It says that it does a very good job in summarizing some of the concepts, helping you understand concepts, make some resource recommendations. It can help you to common issues that you might encounter using GIS software. But it does say that Gen AI is a powerful tool. It is important to remember that it complements rather than replaces traditional learning methods. Combining Gen AI with hands on practice, formal education, and consultation with GIS can provide a well rounded learning experience. So, Gen AI, a good assistant, but a bad master. So, we're going to make use of Gen AI because that's where the world is and that's where the world is going to be. But I also want you to be proficient in using it correctly and ethically. So, in summary, the focus of this course is to teach you the fundamentals of GIS and apply those fundamentals to solve civil engineering problems. We are going to use conventional and modern approaches to GIS implementations, both using GUI based tools as well as programming based tools. Course promotes the proper and ethical uses of Gen AI, particularly its strengths and its limitations, and how it can help you with learning, and some of the don'ts that you need to keep in mind, or some of the pitfalls that you need to keep in mind when you use Gen AI. So hopefully this introduction serves you with some useful information as you prepare for this course. I look forward to seeing you in a classroom very soon. Till then, take care and goodbye.